Good morning, all of you. Now, let's start with the topic introduction to data analytics. Before we start with the data analytics, there are few terminologies which are being used as a buzzword these days. The first most is the data science. First most is the data science. Second one is data analytics, machine learning, artificial intelligence. Now, the question is, what is the biggest difference between these terminologies, or are they same? So if I say data science, it's the bigger picture, inside which it comes two things. First one is data analytics, and the other one is machine learning. Data analytics basically deals with the informations which we see in the data, which has happened in the past. And we talk only about the past data, past information by analyzing, by transforming them. Machine learning, on the other hand, deals with about the future data, what may happen in the future. For example, let's say I have analyzed the financial data of a bank, and I say that in 1992 there was a bank scam. If I'm claiming that in 1992 in the past something has happened, I'm coming with the information that is data analysis. If I am saying in 2025 there's going to be a fraud, that is going to be a part of machine learning. So your data science, data analytics, these are all completely different domains. Only thing is, within data science, you have these. Again, inside your machine learning, you have artificial intelligence, your deep learning. Machine learning, where you try to train a model, and everything, when you say I'm going to predict anything using, let's say, supervised learning, unsupervised learning, neural network, deep neural network, whatever, there are only two criteria using which we predict. First one is the distance, and second one is the probability. Only these two conditions are being used to define the future of any particular task which you are going to perform, whether it be classification, segmentation, clustering. Now, coming back to the term data analysis, where we need to analyze the data. Before this term machine learning was famous, most of the time of a project, if it is being allocated, around 60% of the time is being used or is being devoted towards analyzing the data. And that too, there are three things, which is known as extraction, transformation, and loading, that is ETL, for any particular project. Your 60% of effort is wasted in that. If you see this data, which I have, just a common thing like number of action scenes, just a second. If you see over here, the scenes which are there are two things which is being taken as a feature, number of action scenes and number of comedy scenes. And there are some labels. Suppose I ask a question, like if you have seen a movie, there are 100 action scenes and there are 15 comedy scenes. So what will be the first answer for this? To which category we should put it into? Action. Similar way, we have 20 action and 95 as comedy. Then this 90 and 5 action. And then 85 comedy. Now, the rules which you assume, it's working perfectly fine. But the question arises, if I have data as 50-50, you just have two categories. Now, to which particular category this should belong to? That's the question. I cannot say it's a part of action comedy. Either it has to be action or it has to be comedy. Now, the first thing which we should not do in data analysis, the assumption. I just asked what should be the category. I never said that If the action scene is more, it should be categorized into action, or the comedy scene is more, it should be categorized into the comedy. It was your assumption based on your historical information, the movies from the childhood which we have seen. Same way, we need to feed this information inside the machine and tell them these are your historical data. For example, when you answered this particular question, you took your historical information, your analytical power, and you came to a conclusion if the action scene is more, it will be accurate. But when I asked the second one, you didn't take this particular data into consideration. You never thought of this. You just kept on using your own memory information. So let's see this one, how we can analyze this. I'm just plotting this, and this is comedy. 115, let's say 115 somewhere over here, it will come. It is one, that is action. Then your 20 and 95 somewhere over here, point number 2, that is comedy. Then 90 and 5 somewhere over here, that is again action. And 10 and 85 somewhere over here, that is comedy. If you see, when we plotted the data, these 2 points, that is this first point and the third point, they are close enough and they belongs to the same category. Same way over here, these 2 points are similar, are near to one another, and they belongs to the comedy category. Am I clear? So if I say that if the points are close enough, they will have similar behavior. Suppose a new point turns out to be over here. What should be the category of this point? Action. Great. This is the one nearness we are talking about. Now, how do we measure a nearness? How close we are on the basis of distance. If I'm saying this point is nearer to these 2 points and it is far away from this, that is the distance parameter which we are talking about. And most of the places, if you talk about even the latest Chinese network or deep neural network or anything, they are also using distance parameter, and that too a Euclidean distance, which we have studied in standard 7. Am I clear? Now, coming back to this page again, there are some terminologies which I will be using in my slides, so I will be explaining it over here. First one, these 2 features, you can call it as a feature, you can call it as a parameter, or you can call it as an input. This one, I can call it as a class, label, category, or let's say output. Looking at this particular data, if you have a set of input and you have a set of output associated with it, that means it is going to be a part of supervised learning, which I'm not covering today, which will be covered in the later sessions. If you have only input, it is going to be a part of unsupervised learning. Suppose I remove these labels from here and I simply plot this over here. There will be any difference in the properties of the data point? No. Only thing is I don't know the label names. I will say that this is group 1, this is group 2. That's it. There's not going to be any change in the property. So if you have only data, that is the input it is having, that is going to be a part of unsupervised learning. Another thing, if you see over here, discrete values, and that to a limited one, that means only 2 values are there, discrete. That is going to be a part of classification. If you see over here, continuous value, let's say rupees 10, 15, 20, 30, anything, that is going to be part of your regression analysis. Am I clear? Can we proceed further? Okay. Now, coming to this particular session about data analytics. Why this particular slide is, yes, ma'am. Okay. If you see over here, if I am saying, let me give you an example. I have 6 balls with color red, 2 balls with color black, and 2 balls with color green. Same ball, okay? So there are three colors. I have a simple question. How many groups are there? How many of you say three? Raise your hands. Okay. Now the first statement which I made, that we should not assume anything. You guys choose color on the basis of which you have grouped. If I go with the shape and size, we just have only one group. If we go, that's what the assumption is. We cannot go with our instinct. We will have to look at the data. Over here, there were no labels. There were nothing to compare with. We just had the features, that is shape and color. If any data, if you see where there are only features present, there are no labels associated to it, that is going to be a part of unsupervised learning. Where there comes k-mean clustering, density-based clustering, hierarchical, fuzzy clustering, there's so many. If set of input and a set of output is associated with them, and you build a model, inside that model, if you give a test input, these kind of models are known as supervised because there's something to give a supervision. Fine? Yeah. This slide, why it is important. You talk about any particular algorithm. For example, this particular slide, if I want to compute a distance, I need to have two parameters. That is your x and y coordinate, then only I can compute, right? That is your square root of x1 minus x2 whole square plus y1 minus y2 whole square. You need to have a distance parameter. Now the thing is, just imagine if this particular value is missing. That means only the x coordinate we have, we don't have the y coordinate. We cannot compute a distance with that. Like I said, whether it is going to be a machine learning or deep learning, you need to have distance or you can say the probability. Apart from that, there are no other methods. Fine. So that means I cannot go with a missing value. These type of data which you see over here in the form of rows and columns, these are known as your structured data. Or any particular model for machine learning or deep learning, you need to have a structured data. If that data is unstructured, if there is a missing value, we cannot go with that. We cannot build any model. Shall we proceed further? Yes. So having a proper structure is very important. Now, coming to this particular data set, there are basically three things in case of analyzing the data. First one is your acquisition, that is extracting the data. Second one is wrangling, that is transforming the data. And third one, that is loading for visualization or for the analysis purpose. So there are going to be three things. Either you call it as a ETL, or you call that as an acquisition, wrangling, and analysis and visualization. These terms are used in projects. Now nobody is using the term extraction, transformation, and loading. So you see this particular data set, which has more than 5,000 plus movies, and there are around 28 variables. We will be taking this example and we will be proceeding. Inside this, let's say there are some descriptions given. You have color, you have data type. And durations are given in numeric string. So the thing is, you have some meta information about the data that is being displayed. Now coming to this particular case, I want to know top 10 movies with highest profit. I am not predicting anything. I am going back to my data. I am looking at my raw data and I am analyzing that. That is a part of data analysis. They never said about anything about the future. If the question would have been, which movie will have the highest profit in 2024? That would have been a part of machine learning or prediction. Second one, no top rated movies in the list and also average IMDb. Again, the data I have, I need to analyze it and give the information. Plot a graphical representations or not. Now, the steps involved in this is extraction, wrangling, and data exploration. Sometimes the graphs are very important to analyze the data. For example, if there is a plot X and Y, and you see some kind of this pattern, that means X is dependent upon Y or Y is dependent upon X. These kind of plots, the scatter plots, we try to build so that we can get the information whether linear regression can be applied on that or not. If you see a plot, something like this, that means there are three classes and in a particular plane, they are separated. So I may be going for either unsupervised or supervised. If this have a name, let's say group 1, predefined names are there, we will go for the classification. So again, I'm looking at the distance, nothing else. Fine. For example, this particular data which you have, I need to draw a line and that line is called a linear regression. Now tell me, what is the formula of a line? Y is equals to mx plus c. Same equations, researchers, the data analysts, data scientists have given a name and they have turned this equation to be, this is your regression analysis. Here, this is your intercept, and this is your slope. That means I just have to find a line which can fit into this. And that's what they call it as a linear regression. That is something which we have done in standard 7 and 8. The terminologies have only changed. So these plots are important to get an insight of the data, whether which kind of analysis we can do. Regression, okay, fine, if they have a continuous data by looking at the output. But what kind of regression analysis? Is it going to be polynomial? Is it going to be a multivariate, univariate, or it is going to be a simple linear regression? Fine. So mainly we will be focusing on acquisition, wrangling, and analysis. Data acquisition is the process where you try to get data from different sources. For example, I'm reading a CSV file. So I call that I'm acquiring the data or I'm extracting the data. Same something from I'm extracting from tweets or let's say JSON file or XML file. From different sources, we want to extract the data. Now the thing is, these are some predefined ones. But if you go with the big data where you are having sensors, from different kind of sensors when data is coming, they come in different formats. I cannot have a fixed Python file or any programming language to get that. So for that, they come up with a terminology, a framework, which is known as Chukwa, CHUKWA, Chukwa. It is used to gather information from different sources onto a same platform. Fine. Now, talking about the data is again important. People have categorized this data based on some characteristics. If they see that the data cannot change and there is a data which is changing, they have given it as a name as static and dynamic data. If you go to the books and you see that these informations are given. If you find that the data is a proper structured and some numbers are there and all, and there are some text which is given. So these type of data which you see, these are known as quantitative data or hard data. And these is known as qualitative data. Even for analyzing the qualitative data, let's say I'm passing this information into a LSTM module, NLP language, any NLP model. For that also, again, I will have to give it a structure. I will have to quantify that. Otherwise, it becomes very difficult. Fine. Now coming to this particular case. Structured data, the first example which I showed you, where you have seen each cell, each row and column has a cell, and each cell has a value associated to it. If we have any kind of data in this particular format, we call it as a structured data. That means a data can be represented in the form of rows and columns, and each cell contains a value. If you cannot represent a data into the form of rows and columns, and each cell does not have a single value, those kind of data we term it as unstructured data. For example, images, videos, images. Sorry. If you talk about images and videos, we call it as a unstructured data. Now the question arises, why images are termed as unstructured data if we have a rows and columns? Your pixels are properly arranged. They are not randomly arranged. The thing is, each pixel may have more than one particular value. Each pixel, if I'm talking about a color image, it has RGB. That is why we call the images as unstructured data. There are still debates going on and saying that there is no kind of data which can be termed as unstructured. But some researchers, they believe and they have given this exact difference between them. If a data cannot be represented in the form of rows and columns, and each cell does not have a single value, then that kind of data is a kind of unstructured data. Am I clear? There comes the another data kind of data, which is known as semi-structured data. Semi-structured data are data which are between structured and unstructured. These kind of data, for example, if I talk about Gmail, you have to from body. What goes inside a body, that's of no use. It may be blank, it may have some values text, it may have some tables. So there is a kind of structure which is defined, but also there is a kind of unstructured information in that. So if we have a combination of these two, we call it as a semi-structured data. Is it clear? Am I moving too fast? It's fine? Okay. Sorry? Okay. Now, coming to data acquisition. Like I said, data acquisition or extraction, they both means the same thing. The only thing is how we are going to extract the data. Now, this session is devoted towards the programming language for Python. If you really see, we can have this particular information. There is a library known as pandas. So in this particular, you can read the CSV files. For example, I have import pandas as PD. I'm giving it a name alias pd.read underscore CSV, and I give a file name. It will read the data. But suppose that particular data does not have any header, or I say column names. So in that particular case, I will have to use another attribute. I will have to define header equals to none. Whatever data gets loaded that does not have any column name. And suppose I want to get first 4 rows or first 20 rows. For example, when you are analyzing time series or sequential data, we create a window and we slide that window to get the training data. So while sliding the window, what first 10 information or first 20 information, which one you want to gather, that you can do it while reading this. Now there are two ways. Either you load the entire data into your memory and then you get the first 40, or if only first 40 rows are required or first 20 rows are required, you only read those 40 rows or those 20 rows, so that unnecessary information is not loaded inside your RAM. Am I clear? Okay. Suppose there is any other delimiter. CSV, as the name suggests, comma separated value. In case of comma, let's say semicolon is there or colon is there, or let's say tab separated value. If those are there, you can change the delimiter over here. And all these informations which you are reading are actually stored in the form of data frame. Data frame, it looks like a matrix. It looks like a two-dimensional array But the property which it holds is it can have heterogeneous kind of data. It may have string, it may have float, it may have any kind of data associated to it within a single thing. Yeah, it's just an object name which I have defined. Suppose you have gathered this data and you want to pass it to the model, so I don't need to save it. But at some stage, if you want to save those data back to the system, you have something as 2_CSV. The 2_CSV will help you to save that data frame into your CSV file with any specified delimiter. Now, this particular section which I have shown you, like within pandas, we have read_CSV, 2_CSV. There are different packages as well available. They are customized packages. So the only thing is in Python is you need to know about the packages. Instead of pandas, you may use any other packages to load the data. For example, if you see over here, I want to read an Excel file. So in order to read the Excel file, you need to import this package as OpenPyXL, OPENPY Excel. Using this, you can read about the Excel sheet. Suppose this is the Excel sheet which we want. I am defining the path, and over here I am loading the workbook. Right? The first one is this particular sheet, whichever is the first active sheet, that one I'm trying to load. If I want to get first row and first column, that means only the first cell value. I can use this particular thing. So the only thing is this Python, why it gained importance after 2016. Till 2014-15, there was a framework which is known as R. Have you heard of that? This R and Python, along with that, there was one more Veka. These three were there where people were using them to analyze the data. R was very rich in library at that particular time. Till this date, I guess around 45,000 libraries are there, which are publicly available. But why this Python gained the library importance is they have a good support for the, what you can say, for importing the models, for creating the modules. People can compile their code and they can create their own module as well. You can customize it for reading data from the Twitter. There are Twitter as well. I haven't included that, but for Twitter also there is a library which you can import. Fine? Okay. Then if you want to connect with the MySQL, from MySQL you want to fetch the data, you can use this MySQL.connector library. Using this, you can set the connection host name, username, and password. Once this is set, you can simply use select and other SQL-like commands to extract the information. So till now, whatever we are discussing, we are just discussing about from different sources from where I can get data inside my Python file. Now, this one is your XML file. Now, this is very much being used in the industry because either in the JSON format, XML, or Parquet format, people are storing the data. They don't go with the CSV format. Inside this, you have this model.minidom.class, which helps you to get the file name, and then you type the elements using the tag names which are there. Similarly, if you want to get the attributes based on the name of that, using that attribute, or you can use position parameters as well. Now, the thing is, these particular thing, if you assume that you are going to memorize it, it's very difficult because every time a file changes, set of instructions will change. So it's better, instead of focusing on the statements, you try to focus on the library, and you should be aware of which particular library is meant for which particular purpose. That is much more important. Am I clear? Shall we proceed? Same thing with the JSON file. Like there is a package or library you can call that is a JSON. Using that, you can load the data, read the data, whatever transformation you want to make, and then you can close the data. So these are some file formats which I thought may be important. So I have included that with the syntax. Fine, guys? Now, the thing is, the data which you get after loading, this was the first step of getting the data. Now, the thing is, this data which you have achieved, that is known as a raw data. Now, this raw data needs to be transformed for the analysis purpose or for building up the model. Now, that particular steps which is there, that is known as wrangling. Now, why we are analyzing the raw data? Like I said, for any particular analysis or for machine learning, we need to have a structure, a proper structure. In order to get that, if there are some missing values, how we can handle that? If there is a type mismatch, what should we do? So all those things which we will be covering over here. See this particular format. There is a name, there is some date mentioned, and there is a place. So first came the name, then the date, then the place. And over here, the place came, then name, then date. That means there are three informations present, but they are not in a sequence. If I try to get this data and give it a proper structure, all the names comes in this date of birth and hometown, that means it is called as a processed data. Fine. When they are processing this data, how we can do that? First one is you need to be aware of software packages for data wrangling. That is the first step. Like in order for the entire Excel sheet, how we are going to check whether there is any NA value or not. So there is a function as is NA, dot is NA. There's a function which helps you to get that or null value. Then you need to know the skill for cleaning the data through the pipeline process. That means I said that if there is a null value, then you need to check how to tackle that. Now, please note, if any particular row or any particular column has more than 30% missing values, then we should not go for inserting the data. We should drop that particular column or that particular row. If the industry which is they are following is 30%, if any data is having more than 30% of missing values in a particular column or a particular row, we should simply drop that. So for that, you need to know about how we can do that, and you need to know the skills. And how you can explore the data and how you understand the data, that is much more important. Now, there are four basic techniques which are being applied. First one is this. 30% thing has come. Sir, sir, there is no fixed rule defined in the book. There were two projects which we have done, which we did with the American Express and Cisco. In that particular case, the thing was, if we are going with more than 30% of the data, when we are inputting the values, the model which is we are building up, that is not giving us the good results. And the main reason for that was that when we are inserting the data, we cannot insert the exact value or we cannot impute the exact value. Either the data are inserted using mean, median, or I can say the sequence modeling or using regression analysis. These are data imputations. So if the mean, if you are using that will never going to give you the exact information, neither the median. So if you see that if you're 30% data, if you're having, till that the model can understand. But if you try to increase about that, but that again, it depends upon different data. But if you try to increase on that, the final model, the accuracy which you try to achieve, that will get reduced because we are not providing the exact information. Answer? Why I was asking, why 30%? 30% is it can be 25. It's something like for training we take 70% or 30%, for 80% and 20%. All this thing started, okay, let me put it this way. When this machine learning and this deep learning started, basically it started after the year 2006. If you remember, if you were having internet in the year 1999 or 1998, there were only few organizations who were generating the data and all others were accessing the data. But after this, Google file system, GFS, a paper was published in the year 2004. And after that, people came up with social media. Orkut, there was one Orkut, if you remember. That was a social media where people started dumping the data. That gave us the option, if I'm going for a tea, if I'm going to a hotel, I'm simply dumping the data. Earlier, there was only one organization which was generating the data, other was accessing them. Now everybody is generating the data. Why that happened? That happened because the hardware cost went down. The efficiency of storing the data went down. Now, earlier, there was a ratio of 60 and 40. Whenever you were training the model, 60% were used as the training data. Even before, if you go, there were only 30 for training and 70% for testing. Later on, when the data was getting increased, this changed to 70-30, then it got changed to 80-20, then it got changed to even 99.5 and 0.5. There are some models where we take just 0.5 of data. Why we are taking 0.5% of the data? The reason being it's a big data, which are in trillions. So even if I take 0.5, there will be crores of lines. There will be millions of lines which will be present. So only thing is how huge your data is. If you have a very huge data, then you need to reduce that. If I have a very huge data, even 30%, I cannot go with that. I need to reduce that to 10%. That 30%, I'm telling on the basis of projects which I have done. Fine. So as the number of data are increasing, either for the testing purpose, if you are splitting the data, that has to be reduced, or even for data imputation, if you are doing that, also has to be reduced. The only thing is I should not have a particular row or column where after imputing the data, it is changing the property of that particular row or column. Shall we proceed? Now, there are four things: sampling data, filtering data, removing null values, and text manipulation. Now, what is a sampling data and why it is important? Although after deep learning, nobody has bothered about this thing, sampling thing. Sampling is important because on the entire population, sometimes it becomes very difficult to create a subset, to create a pipeline. So we try to extract some samples from there. Now, what is a population and what is a sample? The best example is whenever there is going to be an election and it is assumed that every person is giving a vote, that is an election, that is your population. But when it comes to the exit poll, they work on sample. They don't go to each and individual person. They go on the basis of gender. They go on the basis of income, on the basis of caste, religion. They try to get some samples. So samples, if I say, if you see a data, here you have column 1, column 2, column 3. And this is row 1, row 2, row 3. If I am selecting on the basis of row, I have taken first 40 rows. That means I will call it as, the terminology is sampling. If I'm selecting only column 1 and column 3, that means out of the features, if I'm selecting only 2 features or 3 features, that is known as filtering the data. So please remember, sampling is done when you try to consider all the columns and a subset of rows. And filtering happens where you consider all the rows but a subset of columns. Am I clear? Then coming to removing the null values. Let's see over here. When I am extracting this particular information, this is the row information I'm trying to get. This is a set, we call it as a sampling. Even when you go for machine learning, building a small machine learning model, you try to sample out the data in the form of training. Have you ever checked and see that whatever data you have taken it for the training, is it representing the entire population? In 2014, everybody said that the Congress might come, but there was only one channel which said that the BJP, and with the exact number it came up. You remember the name? Chanakya. Because the sampling which was done, it was representing the entire population. So if you are trying to build any model or you're trying to analyze anything, if your sample is not representing your entire population, you will never get a better analysis or a good prediction. Am I clear? So in order to remove this, in case of machine learning, if you go there, people are using k-fold validation. K means number. For example, if I'm saying 10, so my entire data will be distributed into 10 subsets. Did you get my point? If I say 70-30, that means 7 subsets I will take it for training, 3 subsets for testing. Then I will reshuffle that in such a way that at least once each subset goes into the testing set. After that, after all those iterations, I'll take the average and I say that this is the accuracy of my model. Am I clear? So sampling is very important. People earlier, there were hypothetical testing, there was Z testing, there are so many statistical testing. But when this machine learning and deep learning came, people are not entering into the statistical methods. Fine. Now coming to this particular case, selecting the features. Now the best example for this is the action movie and the balls. You assume that this particular column will give us the best result. Like if the action scene is more, it's going to be action movie, or if the red color, green color, on the basis of colors you decided. We should not assume that this particular column will give us the result. Sometimes it turns out that the best value which we have dropped, that might be useful for this particular case. Do you know the case of the car and the ice cream case study? Have you heard of that? Who has heard of that? A case study of a car and ice cream. That is the best example of data science. I'll ask you a question, and in the end, you will have to tell me the answer. A family purchased a car. If I'm not wrong, it was a Ferrari. They purchased that car, and after 2 days, they went back to the showroom and they went with the complaint. The complaint was, whenever I go out with my family, and if I'm having a chocolate ice cream, my engine starts while returning. But if I'm having a vanilla ice cream, my engine doesn't start. This was the complaint which was lodged officially. And same thing, the service owners, they didn't pay any attention. They said, no, it's just an assumption, you go. Next day again they came, and it went in such a way that he started writing letters. It came in the newspaper. Then the company owner decided that, okay, an engineer will go with you. They will have a lunch with you. They will go for ice cream. The engineer had a lunch with them, a dinner with them, and they went for the ice cream. And engineer was shocked to see that whenever they were having chocolate ice cream, the engine was starting. And next day when they were having vanilla ice cream, the engine was not starting. Now, even the company were in a shock to realize what is the relation between this ice cream and the engine. After around 6 or 7 months, they came up with this analysis. The time consumed to eat a chocolate ice cream is less as compared to eat the vanilla ice cream. Chocolate ice cream melts faster as compared to vanilla ice cream. And that was in a cold country where the temperature is around minus 32, minus 20 degrees. So your engine gets cooled and it becomes difficult to start. And that was the relation. Now, why am I giving you this question, this particular example? If you search ice cream and car relationship, this is a very famous case study. And this case study is taught in each and every MBA school with the assumption that you should raise your voice. You should raise your voice, you should ask something to the faculty. And second important thing is, you should not assume anything in the case of analysis. There must be a relation. In 2004, when the first paper came, where they said that on the basis, not in 2004, I think 2007 or 8, they said that on the basis of Twitter data, I can predict the stock market. Later on, it came and it was proved based on the Twitter stock market prediction can be monitored. If there's a negativity, if there's a bomb blast, disease outbreak, stock market will go down. If the GDP of the countries are increasing, stock market will go up. Because of this Ukraine and Russia war, last 1 year, the stock market was down. Now it is recovering. So everything, whatever is there, they have some relation. And that is why it is important figure out which particular columns may be necessary for you. That's why in deep learning, they said that we should not drop any particular column. We should send all the data to the model. Let the model decide. Am I clear? These things which we are discussing, this is for the analysis purpose, not for the prediction. Fine? But sampling still we are doing. But this filtering step, now they have dropped it. Coming to this null values. If you see over here, let's suppose 1, 2, 3, 4, 5, 6, 7. There are 7 columns. Out of this, if you just assume if few values are missing, if I try to impute the data, the thing is this particular row will not have any good values. And how this data imputation happens? It happens, I will try to see the mean of this or a median of this, and I will insert that value over here. Now the question comes whether we should go for mean or median. So for that, again, I will ask you one question. I am a owner of a company and I am an employee. My salary is 1 crore rupees. You have to calculate and tell me the answer. I am an employee and I'm the owner. I am having 1 crore salary. There are 4 other employees whose salary is just 100 rupees per month. My salary per month is 1 crore. Other 4 are having 100 rupees per month. My simple question is, what is the average salary of an employee? 20 lakhs? Okay, first these two people said 20 lakhs because they took the average. Average doesn't mean that it's a arithmetic mean. It's a central tendency where we should say that 50% of the data, what it is representing. If you go with the mean, in that particular case, there will be 20 lakhs. But 80% of the employees, 80% of, you said median, 80% of the employees are getting 100 rupees. But if you go with the median, in that particular case, 100 is the right answer. Now I will come with the second question. I am a company owner and you guys are an investor. I come to you with a scheme that if you invest in my scheme or in my company first 99 days, you will be at a loss of 1 rupee per day. And on the 100th day, you will earn 10 lakhs. So as a investor, are you going to invest in my company? On what grounds? How did you calculate the overall profit? Mean? You or median? Which one did you select? Mean or median? In this particular case, we will go with the mean because if you go with the median, that is -1. That will show that my scheme is at a loss. But overall, I'm in a profit. Only -99 I have lost, but I have earned 10 lakh rupees. Why I'm making this question is, the thing on the basis of domain, you should select whether we should go with mean or median. If in this particular data you find that the domain doesn't allow you for the median, you go with the mean. Or if you find that this doesn't go with the mean, then you can go with the median. For this, you need to have a domain knowledge. Without a domain knowledge, you cannot do anything. Am I clear? Second thing, what you can do is, we can use sequence modeling, where we can insert the data using sequences, or using some regression techniques, we can insert the data. We can build a model, we can insert the data. But only thing is, if you see that majority of the values are missing, in that particular case, you should drop that particular row or drop that particular column. Fine? Shall we proceed? Sorry, sir? Yeah, it doesn't make any difference. See, the only thing is Why this was important, I said, earlier we didn't have this deep learning techniques. We had very small data, and that too with the limitation because of the hardware cost. If you see in the purchase of single pen drive in 2001, it used to cost around 3,500 bucks, that too for just 256 MB. Right now, in just 200 rupees, I can get around 128 GB or 64 GB of pen drive. The hardware costs have gone down. That's why everybody has started dumping the data. So from the entire thing, if you lose anything, that doesn't matter. But if you have a very small amount of data, we cannot simply drop that. We will first try to insert it. Otherwise, we will lose the information. Sorry? String value, if it is missing, what you do is, it will have to first check whether that is coming up in a case where it's a discrete value or not, whether that means there's a set of strings or not. For example, car company, Maruti, Hyundai, like that, if it is coming, or there is a email ID. If email ID is missing, you cannot do anything. But if car company is missing, what we can do is, no. What we have to do is, we will have to give it a number. Each string, we will have to convert into a number. That's it. And using that, we can insert it. But again, it depends. If that the company has to be the main focus, then we cannot do anything. But nothing. See, in this particular case, if you are converting a text into values, let's plot that. This is 0, this is 1, this is 2, this is 3. This is Maruti, Tata, Hyundai, Kia. If any value comes, let's say in this particular direction, any particular thing comes, let's say price or anything, if it belongs to Maruti, it has to be present in this particular place. Straight line. This will again go in a straight line. Am I clear? Fine. Let me put it another example for this. Because if you drop that, you will lose information, and losing information creates big disaster. Suppose I have 2 points, 2,2 and 2,2. So I have 2 axes. Each axis I am trying to represent over here in the form of planes. Each column is represented as an axis, and it is assumed that each axis has 90 degree. Till 3 degree, we can visualize it. But when it goes to 4, 5, 8, if you go with the protein data, it has 16,000 dimensions. And each dimension is 90 degree to each other dimensions. So we cannot visualize that. But losing the information, what does that mean? Right now, both the points A and B seems to be at the same place. But if we add a second dimension, sorry, the third dimension, let's say 0 and 2, you can see that there is a segregation of the point. What I'm trying to make it over here is, like I said in the starting, distance and probability, these are the only 2 things. So if you drop a dimension, like if I'm dropping any particular column, that means I'm reducing the dimension. Reducing the dimension, that means for me, the 2 rows will A and B seems to be at the same place. But if I add the third dimension, it goes to a different height. The distance has increased. Fine. Whenever you are dropping any particular column, it comes with the curse of dimensionality reduction. Please note, there is a curse of dimensionality reduction, which says that if you reduce the dimension, you will lose some important informations. Filtering is not required. Filtering nowadays in deep learning, nobody does the filtering. No. Sample part, yes. See, these things were there, this extraction, this wrangling techniques were used earlier when we have very less amount of data. Fine, there we didn't had any other ways to analyze all those things. The statistical methods which we were dependent upon, that was using correlations. Fine, using the correlation, we try to find out how these two are correlated. And manipulation. Sometimes we try to append some information on that so that we get a meaningful thing. Suppose instead of Bangalore, I'm transforming it to Bangalore, or I'm just adding Mr. So this is some manipulation you are trying to do. For example, RGB, sorry, you have a grayscale image. In grayscale image, I want to do a clustering. The simple step is, if I want to do a clustering in grayscale image, at 0 to 125, you set it to 0. And 126 to 255, you set it to, let's say, 255. So the entire image you will find 0 and 255 pixels only. So what I'm trying to do, I'm trying to manipulate the data. If you have heard of data augmentation, how many have heard of that? Data augmentation in deep learning? Okay. In deep learning model, there was a requirement of huge amount of data, but still, till this date, we have very less amount of labeled data. So what people did is, using the same images, they tried to bring some transformations. For example, they rotated the image to 5 degrees, then again 5 degrees. Using that, they increased the sample size. Or let's say they have increased the brightness or the luminance or anything. So making some transformation in the values, they try to increase the data set or come up with the meaningful information. That's it. So these are the 4 things. Sampling is still very important. But if you're going with the deep learning methods, filtering is something which has been dropped. Actually, in no research paper after around 2014 and 15, I have not seen that anybody dropping any particular column. They are even adding the columns. If you go with the BCI, brain computer interface, where there are only signals, people now are incorporating statistical parameters to it. Fine. And sometimes what happens is there are some, maybe let's say in this particular text, there are some special characters which are being there. So we need to remove those special characters. That also comes side handling. Now coming the last sections, the process data. If you have done everything and you are ready to have a structured data which can be passed to the model for analysis or for machine learning building, there are 3 kinds of data will get generated. First one is tiny data, second one is metadata, and the third one is log file. Most of the researchers, most of the academicians, they do not follow this particular format, but you should go with this. Why? Tiny data which will describe about each and every value. Actually, this is the data which we are using. We are discarding the other 2 data. That means the structured format which we get, we call that as a tiny data. Metadata is the information about the data. Some of the databases which are there, they simply give the data, they do not give the metadata information, which is very much important. Fine. And the third one is actually the steps involved, like for the reading the file, I've shown you some Python codes. After that, for selecting the samples, filtering, data manipulation, you have created a set of line of codes. Those line of codes are known as log file. That is your script file, you can call it as a log file. So metadata is also important. Any data, anyways, you have to use a log file is there for processing the data. After processing data, the process data has these 3 parameters. Fine. So I'll rest over here. This is what, after you have processed the data, now you are ready for analyzing the data for machine learning or deep learning. If you have any questions, any queries, yeah, please. Tiny data is the actual data which you are holding. For example, in the images, you have read the image and each cell has some values. Let's say a grayscale image, some pixel values are there. If you're looking at the pixel values, I call it as a tiny data. But this information that this particular image is a grayscale image, that is the meta information, metadata, information about the data and not exactly the data. If you're showing the data, that is a tiny data. If you're showing information about the data, that is a metadata. Log file, sir, is the script file. The Python script or the C language, or let's say in R or Java, whatever line of codes which you write, that is known as a log file. The script, the code file, you can say. The term is log file for that.
Is there any image? Then after extracting the data from the image, that is that tiny data.
Tiny data, yeah. See, when you are reading the image, your image will get, if it's a RGB image, you cannot read in 2-dimensional. That has to be into 3-dimensional. So for 3-dimensional, you have to give it a structure. So if you have given a structure loaded in the data frame, why call that as a tiny data? Yeah. Feature selection and feature ranking. See, feature selection is the one among these which are the most important features. But still, the other features are being used to analyze that. We are not dropping it. But yes, sometimes those features selected are used just in order to reduce the complexity of the model. And after using feature selection, they are still trying to reach that particular accuracy. Yeah, it's happening. Feature selection, feature ranking is also happening. Feature extraction is also happening. Yeah. Any other questions? Yes. See, the first thing is nowadays, like if you go with the deep learning model, the researchers and the academicians, they have already claimed that this deep learning is a black box model. Where when you are sending the images, they initially each layer of the CNN, they are calculating the edges. But which shape of edges, we are not defining that. It is computing on its own basis. If two faces are there, what was that particular feature on the basis of they have discriminated it? It is difficult to answer. For that, again, they came up with another model which is known as explainable AI. They will show you a feature. This was the section using which this particular model said that it's you. So that is explainable. There's line, shape, and you call that this one grad cam. These are the method. But before 2020 or 2019, I guess, this deep learning was considered as a black box. You pass the image, you predict, you classified. But what was that particular feature which differentiated between two different classes? That was difficult to explain. That's why people were dumping the entire data. Yes, sir.
So first question, आपने कहा कि image is unstructured.
Correct.
But sir, अगर हम image को देखें, image is made of the points.
Yeah.
So
So
you have a points in here.
yeah,
And
there.
point has certain coordinates, x and y. So how it can be?
Yes. Though my complete statement, which I said, if a data is represented in the form of row and column, and each cell has a single value, then we call it as a structured data. If you take a color image that contains each pixel will contain 3 values, RGB, that's not containing a single value. That's why these images are termed as a unstructured data. It comes into the category of unstructured data.
There are certain things, ऐसे मान आप CMM होता है, coordinate measuring machines. कि आप जो है मान लो आप उसे मैं किसी ड्राइंग को कर रहा हूँ, और ड्राइंग को देख के उसके वो पॉइंट्स जनरेट करते हैं कि ये क्या क्या होगा.
Okay.
So that is what.
See, that's what I'm saying. Like I said, the hard data, soft data. There are some criteria on which the data was separated. The discriminations between different data was generated. Let me just go to that particular slide. Static data, depending upon whether it's a fixed or that is continuously generating. Same way over here, if you find that any particular data is having a single cell value, then it is termed as a structure. That is some on the basis of some properties, they have tried to discriminate them. If you come up with another property, you can come up with another terminology. Like some people till day, they believe that there is nothing as semi-structured data. Why can't this particular category go inside an unstructured data? Fine. So this is just some property where on the basis of which they are differentiated. And over here, they have mentioned that based on a single cell value.
Second, आपने तो कहा कि जब आप start किया तो आपने कहा कि
Data analysis.
उसमें आपने कहा कि इसमें आप पास there is certain which is दोनों को रिलेशन है। मैं प्रीवियस डाटा से फोरकास्ट करता हूँ कि आगे आने वाले टाइम में डिमांड की क्या वैल्यू होगी। मैं एनालाइजिंग कर रहा हूँ प्रीवियस डाटा को और मैं उससे फोरकास्ट कर रहा हूँ कि फ्यूचर में क्या हो रहेगा। तो मतलब दे आर नॉट इंडिपेंडेंट, they somehow they are dependent.
See, in the class also I said this thing. After processing the data, after analyzing the data with the processed data which we have, now that data will be passed for machine learning or for the data analysis. For example, if you're going with the regression analysis, like you correctly said, if I cannot see that the two variables, whether they are directly dependent or not, if these are not directly dependent, we cannot go with simple linear regression. So this data analysis, they are using to find a trend. If there is a forecasting, there is a future prediction, then that's a part of machine learning. This machine learning is using this data analysis as a mean, as a method to get the information, and using that information, they are proceeding further for the future prediction.
Only for this linear model,
No, not only for
there are certain n number of points which are scattered points. If I draw a line so that the sum of the deviation square that is minimum, so that represents my equation of that line.
Correct. Yeah.
Okay. It may not be a straight line.
That's why the complete equation of complete equation was beta naught plus beta 1 x1 plus epsilon. This epsilon is the deviation which you are talking about. So there will be an error. See, if a particular model, if you say that I have achieved 100% of accuracy, that means that is no more a research problem. That means you came up with the solution. So in all the research paper you see, even if you go with the segmentation with the Pine and all other data set, you'll see that they will come with the accuracy as 99.99, 99.991, 99.999. But they are not saying 100%. Even the airlines, they say that you are 99.99% safe. They never say that you are 100% safe. Exactly. So your prediction cannot be true always. Exactly. Yeah.
बात ये है कि अगर हम वो बहुत ज्यादा नॉन लीनियर है और हम लीनियर मान रहे हैं एरर वैल्यू है
वो बहुत हाई होगी,
बहुत ज्यादा होगी तो फिल्म में उसको
we have to, yes, we will have to come up with a non-linear model. That's why you can go with the polynomial regression or quadratic regression for that particular case. But analysis is important. Without analysis, without analyzing the data, and without the domain knowledge, we cannot simply apply the machine learning. Yes, sir.
सर एक और उसकी तरह आपने सैंपलिंग की बात कर रहे थे।
हाँ।
अब सैंपलिंग में जैसे क्वेश्चन भी होते हैं आजकल, अब पूछा जाता है कि कौन जीतेगा तो
करेक्ट, या
तो अब बात ये अब rather the sampling represent the true picture of the population.
Correct.
Suppose particular जो है वो middle class कितनी है, lower class कितनी है, ठीक है? तो अब मैं suppose सारे जो क्वेश्चन है वो मिडिल क्लास से पूछ रहा हूँ,
That is
मैं नहीं जा रहा हूँ, ठीक है? तो also मेरा सैंपल साइज बड़ा है.
Exactly, but that is of no use.
But it would not yield the relevant part.
That's what happens with the exit polls. That's what exactly happens with the exit polls. That's why they are never able to came up with the true picture who is going to win, because they are not considering the entire population. If they consider the entire population, then there's no use of this election. So because there is a lots of money invested for conducting the election, you cannot go each and every organization go with the exit poll, going at each and every door and get the information.
वो उसके हिसाब से जाएगा। मान इस प्रपोर्शन के अंदर पॉपुलेशन के अंदर एक बिजनेस स्टार्ट है 70 that but to start out.
Yeah, so for that only they came up, and this machine learning and deep learning are there. They are using this k-fold validation, so that at least once everything goes to the test data, then you can come up with the accuracy.
And so moreover, जैसे हम क्वेश्चन भी पूछते हैं, कई बार क्या होता है कि आप सीधा पहले ये नहीं पूछते कि कौन ये बनेगा, कौन सी ये बनेगा, तो पहले आप कहते हैं कि आप जो है किस चीज को आप ज्यादा वेटेज से, आई मीन लॉ एंड ऑर्डर को देते हो, आप इंटरप्रेट को देते हो, आप किसी और चीज को देते हो, एंड वो देते हो। ताकि होते हैं कि कोई भी एज ए सीएमओ वो देखो उसको सेटिस्फाई नहीं कर सकता। देखिए रिजल्ट होता है ना, वो प्रोडक्ट होती है, मैं इस चीज को फर्स्ट नहीं, इस चीज को सेकंड दूंगा। तो इट मींस कि जब मैं डाटा ले रहा हूं, ये शुड बी सम वेटेज that should be associated with that.
Correct. If you see this linear regression part, sir, this beta naught and beta 1, these coefficients are nothing but they are the weightage only. When you are passing that, if I set this beta 1 to 0, it means I'm not considering that data column. So weightage is actually given to, even in case of not only in regression, for classification, when we go, we try to give a weightage. The coefficients when we get, that is actually the weightage which we are giving, but not exactly on our assumption. It is on the basis of the model which sees the inside the data. On basis of that, it gives. So obviously, there is a probability, there is a distance. There are only two things which is there for this entire machine learning, deep learning data science.